What I want to do on this video is go through a couple of molarity problems, and if you haven't been part of the conversation in class about molarity and don't know the equation yet, or if you missed it along the way, this is the basic equation. Molarity in a solution is calculated by taking the moles of solute divided by the liters of solution. So basically we're taking the amount of solute per volume of solution, moles per liter. Now that's 3 units, molarity, moles, and liters, but we can extend that out and include grams of solute because it's easy to convert grams and moles on any solute, and we can also use milliliters of solution as our volume and convert that to liters. So there's really sort of a main 3-part equation here, and then beyond that there are, in the green here, 2 different sort of extended units we can use, grams of solute and milliliters of solution. So depending on the problem, you may be using just the black parts of the equation here, and solving for one of those 3, or if the problem needs you to, you might be solving for one of the green values or using those to solve for one of the black ones. So there's really up to 5 different parts of this equation, and which units you need to use and which parts of the equation you need to use are based on what information is given in the problem. What I want to show you just is a couple of example problems that show different calculations using this equation. So we're going to start with number 3. If you have a copy of the problem sheet, this is number 3 on there, and if not, you can just follow along with us. Number 3 asks, what is the molarity of 5.30 grams of sodium carbonate dissolved in 400 milliliters of solution? So you've got the question asking for molarity, which of course is here on the left. We've got molarity as the kind of main value here, and you're being given 5.30 grams of sodium carbonate. This is our solute. Okay, so that's dissolved in something. In this case, it's dissolved in 400 milliliters of solution. So this is your solute, and it's giving it to you in grams. So in the previous equation then, grams of solute, that's this value right up in here, 5.30 grams of the particular solute, sodium carbonate, and it's dissolved in 400 milliliters of solution. So we've got grams and milliliters. So again, grams and milliliters are our green values out here. In order to use those to find molarity, we're going to have to convert grams of solute to moles, and we're going to have to convert milliliters to liters. 2 very simple and familiar conversions by now. So it doesn't matter really which one you start with. Let's start with the 5.30 grams. So if I've got 5.30 grams of sodium carbonate, I need to convert that to moles because it's my solute. And for sodium carbonate, we'd go to the periodic table and add up, find that 1 mole of sodium carbonate has a mass of 106 grams. Now we've been doing this for a long time, and I suspect all of you are very good at adding up sodium carbonate's molar mass or any compound's molar mass, so I won't go through how we get that. But if we divide this out, the grams will cancel out and you'll be left with moles. In this case specifically, you'll have 0.05 moles of sodium carbonate. It takes 106 grams to have a mole. You've only got 5.3, so a small amount of solute here, dissolved in 400 milliliters of solution. So that's moles. We've got that part found. Now we need to turn these milliliters into liters. So 400 milliliters, convert that to liters. 400 milliliters, if you remember from your metric system conversions since way back in grade school, hopefully you know that 1 liter is 1,000 milliliters. There are 1,000 milliliters in a liter, and so to convert we simply divide 400 milliliters by 1,000 and the milliliters will cancel, and my volume is 0.4000. I'm keeping my significant figures, liters. So I've got 0.0500 moles of sodium carbonate, I've got 0.4 liters of solution, and I can simply divide those 2 into each other to get my final answer. So molarity is moles over liters. 0.0500 moles of my solute, in this case sodium carbonate, divided by a volume of 0.4000 liters. And when I divide that out, my calculator should tell me I've got a solution concentration of 0.125 moles per liter. And the unit that we use for that is a capital M, usually in italics, but at least to make sure that it's clearly a capital M as you're labeling this and not a lowercase m, because that means something else. So 0.125 molarity, or molar, like the tooth, sodium carbonate. That's how we would read that, 0.125 molar sodium carbonate. And that molarity symbol again right here is equivalent to moles per liter, or molarity. And so either moles per liter or molarity would be okay as a capital M, But there's our final answer, 0.125 molar. So we converted grams of solute to moles and put that on the top. We converted milliliters of solution to liters and put that on the bottom, and that gives us our molarity, 0.125 molar or molarity sodium carbonate. And you should always label with not only the molarity symbol, the capital M, but also the solute.